First concept has to do with percents and probability, and these are basically the same thing. They're pretty closely related. Okay, percent, just think about what the word percent represents. Okay, per is a word that represents divide by, and cent is the prefix for 100. So a percent is just the number divided by 100. Okay, and so if you're looking at 32%, is 32 divided by 100, which is 0.32. So you do need to be able to kind of work back and forth between the percentage form and the decimal form of that percentage. Okay, but that's all it is. It's just a relationship of dividing by 100. Okay, so if you look at like this first example right here, if we just start to translate this statement directly into an equation, you have 7 translates into equals P percent. So again, if we convert that percent into divided by 100, of translates into multiplying, and then 25. So what we've created right here is we've just gone word for word and we've translated this into and rewritten it as an equation. And so if you work through that problem, 25 goes into 100 4 times, multiply both sides by 4, and you get 28 is equal to P. So 28% is your answer. Okay, now notice this P value is not asking you to find the decimal equivalent to this. Okay, and so if you wanted to confirm, is it true that 7 is 28% of 25? Well, if we take 28%, so 0.28, that's the decimal form of that, of times 25, it does show that 7 is in fact the answer. So we can confirm that yes, that is the case. All right, so see if you can answer this second question. What percent of 275 is 66? Can you calculate that number? Again, if you wanted to, you could just manually translate this into an equation. So what is our unknown, right? So we can call that x percent per 100 of is times 275 is equals 66. And so if you wanted to translate this directly here, what you could do is now calculate, if we take our 66 and we divide by 275, right? We divide both sides by 275. These cancel. We can then multiply by 100. So here, if we then multiply by 100, we get our answer of 24%, and so that would be our solution. Okay, so one way that you're going to be asked to deal with percentages is just to kind of use that definition that you're dividing by 100. You're taking percentages of and translating that into sort of the equations or expressions. Right. The next thing that you would be asked to do would look more like these two problems where you're finding and applying the percentages directly as decimals. Okay, so I want you to see if you can answer those really quickly on your own, and then I'll talk through how to use the decimal form to either interpret or answer the questions. Percent sprouted. So if you think of that of taking a total of 700 times 60%, so per 100, you can now see how the 100 cancels. 7 times 6 is 42, times that 10 is 420. And so that would give you your solution for that. Again, if you just multiplied it through, 700 times the 60% as a decimal is 0.6, right? So if you know the decimal percent, you can, or the decimal form of that percent, you can just enter it, and that would still confirm that you have that 420. Okay, and for the next question up here, what you're doing is taking the values they give you and you're finding what the decimal form of that is and then converting that into the percentage form. So if you have 600,000 total beads and 540,000 are silver, and you want what percentage are silver, so if you take the total possible that are silver, or the total that are silver, divided by the total possible, and what you can see is that these factors of 10 cancel. 54 and 60 have a common factor of 6. 6 goes into 54 9 times, 6 goes into 60 10 times. So this is 0.9. 0.9 is 90%. And so that would be your solution there as well. Okay? And if you just took the 54 or 540,000 and you divided by the 600,000, you would see it's the decimal 0.9, but you are being asked to find it as a percentage, which would be the 90%. All right, in addition to just the calculating, you'll also be tasked with finding percentages based on story problems. And so I want you to see if you can apply this first one here, and then I'm going to talk through the second one separately because it involves a slightly different concept. And so see if you can find that middle one first. So here again, percentages allow you to make a prediction based on sort of a survey, right? So if you say that 40% of the people surveyed say they're going to enroll in that program, that means that 40 out of 100 are going to be in that, and there's a total of 15. So if you took 15 times 40 out of 100, which cancels, 10 and 15 have a common factor of 5. 5 goes into 10 twice, into 15 3 times. 2 goes into 4 2 times. So 2 times 3, which equals 6. That's going to be the number that will continue out of the 15. And once again, you can confirm that. If you took 6 divided by 15, you would see it's 40%, which is what your question is asking you to find. All right. One of the ways that you will likely see percentages being used is this idea of stacking percentages. And you stack a percentage when you have markups and discounts. Anytime you're working with markups and discounts, use the remaining percentages. What that means is if you're marking something up 10%, don't calculate with 10%, calculate with 100% plus 10%, so 110%. If you're calculating with discounts, so let's say you're discounting it by 20%, don't calculate with the 20% discount, calculate with what remains. So if you remove 20% from 100%, you're left with 80%. And so use the remaining percentages, and then you're just stacking them. You're going to multiply. You're going to take 110% of one thing times 80% of the other thing if you're dealing with, again, markups and discounts. So here, if you're looking at this problem, and I'm just going to kind of walk you through this, you have an original price of $17, right? So this is being marked up by 261%. So in decimal form, 261% is 2.61. And so you're going to use that remaining percent. So you're multiplying the price by 2.61 to get the selling price of this item. Now, after that price is marked up, there's a seasonal discount at the end of that where it's 60% off, right? So you're discounting this price now by 60%. So rather than trying to find what is 60% of this and then subtracting that from the total, just use the remaining percent. So if you take 60% off of something, how much are you going to be left with? 40%. 40% is represented as 0.4. And so this calculation right here is going to give you your solution. So 17 times the markup, 2.61, times the discount, which you're left paying 40% of that remaining cost. And so the overall price is going to be 17.75 approximately for that item. Okay, so again, that's stacking the markups and discounts all together into one. All right. So we're still going to kind of talk about percentages here, but I'm going to add a new concept of probability. Probability is a value between 0 and 1. And it pretty much equates to percentage chance that it's gonna, the likelihood that it'll happen. 0 is 0%, 1 is 100%, so any decimal in between means that it has that percent chance of happening, right? So if you have a probability of 0.3, that means that there's a 30% chance that it happens. And so probability is really closely tied to percentage. And probability is calculated as the letter P, is the ratio of the number of desired outcomes divided by the number of all possible outcomes. And we'll kind of talk about this, or actually we can talk about it right here. Okay, so I want you to see if you can just apply this strict definition to the problem to the right. It's a pretty straightforward application of how probabilities would work. All right, so here, if you're finding the probability of selecting a yellow tile, so what are the number of possible yellow tiles? How many tiles could you randomly pick that are yellow? So you see that total, there's 90 possible yellow tiles that you could select, out of a total of how many tiles at all possible? So the yellow, the blue, and the red all combined, 215. So 90 out of 215 is going to be your probability. And so 90 divided by 215 gives you that probability, which it will take here to 4 decimals, so 0.4186. So that would be approximately a 42% chance that if you randomly select a tile, it would be a yellow one. Okay. All right, so that's where probability comes in, and it just plays off of the ideas behind calculating percentages. All right, so these are these remaining questions here are a little bit more challenging types of questions. So again, I'm going to just kind of talk you through the process for it. All right, so this first one has to do with like the voting and using sort of the percentages or possibilities to find how would you calculate total votes based on sort of the probability of a certain thing happening. Okay, so here it says the radio show states that 5 times as many people vote in favor of the proposal as against it. So for versus against. Okay. And so the first thing is that 5 times vote for versus against. So for is going to equal 5 times the against, right? So that's just a verbal model of what they are proposing here. Okay, now the second part to this is it gives us that there are 6,000 more people that voted in favor than against. So if there's X people voting against, then that means the number voting for are 6,000 more than that. So X plus 6,000, right? So that's the relationship that we're looking at. And so now if we take these and we plug it into our model here, the number of 4 I can express as X plus 6,000. And that's equal to 5 times the number against, which I can express as an X. And so here is my equation that I can use to calculate this answer. And so if I subtract X from both sides, I'm going to write my answers over here. I get 6,000 is equal to 5X minus 1X, so 4X. Divide by 4, and I get 6,000 over 4, which is 1,500. So X is equal to 1,500. The question is asking how many voted against. Against is my X value, and so the solution is 1,500. Now, it's often a useful idea to verify what you have. If I then took this and it says that 5 times as many people voted in favor, so if I took 5 times this number, is this number also 6,000 more than voted? Yeah, so it confirms on both ends there that you've found the right value. All right. Let's look at this next problem that has to do with, again, a concept that was just sort of included in the SAT, and it's this idea of margin of error. If you have a % margin of error, all it means is it's this tolerance level. Okay? It's the same kind of thing I do with your answers on problems that I give you that ask you to round it. I give you a tolerance level for your calculations. Okay? And that's all this is saying. So if you know that your survey says that 35% of the people have chosen or are surveyed and answered a certain way, what the margin of error means that you're going to take that and you're going to add and subtract. So it's plus or minus whatever that % margin of error is. So what this means is that on the lower end, you're dealing with 33%. On the upper end, you're dealing with 37%. I'm going to write those as decimals here, right? So this gives us where the values have to fall between. Okay, now it gives you a sample of 1,500. So like it does include these numbers that's not going to be part of this calculation, but they're numbers that are somewhat distracting. Just that's where the 1,500 results from. So the 1,500 is the sample size. Okay, but this is asking you, what's the total number of people in the population who support the legislations? What's the plausible value for that? So more than likely it's going to fall between this lower limit and this upper limit based on the margin of error and the results of the survey. So if I take 33% of the number of people that are predicted to vote for this, and I take 37% of that same number of people, this is going to give me the values that my answer should fall between. So 0.33 times 63,500 and 0.37 times 63,500. My answer needs to fall somewhere between those two, or should fall somewhere between those two values. So if I look at this as my lower value and my upper values here, I'm looking for the one answer that falls somewhere between those, which would be this answer choice C, the third answer choice for that. All right, I want you to try this last question here. The concepts behind answering this question are not challenging, but the application of them is a little more challenging. Okay, so I want you to see if you can answer this question on your own before I talk you through it. Okay, or are you going to fall kind of victim to what the common mistake would be in answering that? So probably the most common mistake that's made here is to misread the question. Okay, so make sure you're reading the questions carefully. Okay, and this one, you're given these poll results. The total number of people in the voting population is 9,207, but there's 837 that took this poll. So you're going to base it off of those percentages. And the question isn't how many votes did Johnson get or how many votes did Monroe get. The question is by how many votes would Johnson win. So more than likely what you're looking to do here, or like the right way to go about solving this, is to find how many total votes could you expect Johnson to receive, how many total votes would you expect Monroe to receive, and then take the difference of those, and that's going to be your answer. Okay, so the first thing would be the probability of voting for Johnson. So the probability of voting for Johnson is going to be 479 out of those 837. So if I take 479 out of 837, so that's going to be basically a 57% chance that the vote will go to Johnson. Well, out of the total of 9,207, so if I take that measure right here and I multiply by the total, 9,207, the predicted number of votes would be 5,269. Notice that's one of the answer choices. It's likely going to happen, like knowing where your distractors come from on the SAT is a useful thing to keep in mind. If we were finding what's the probability of the vote going to Monroe, then that would be 358 out of the total 837. So if I calculate that probability, 358 out of 837, so that's about a 43% chance of those 9,207 votes go to Monroe. So again, if I multiply this by 9207, I get the number of votes you can expect Monroe to receive, 9338. Also notice that happens to be one of the distractors. But the question doesn't ask me to find either of those. The question is asking by how many votes would Johnson win? And so if we took this 5269 and we subtracted the 3938, this is the number of votes that he would win by based on those projections. And so that's the actual question that's being asked right there. Okay. And so again, it's tricky in that be careful that you are reading what the questions are asking you to find. All right. So that's dealing with probabilities and percentages. It's under sort of the topic of working with data and problem solving. All right, the next thing that I want to talk about has to do with statistics. Right, and so the concepts that we're going to look at with statistics are frequency. We're going to come back to this slide though in a second, because the main three, or the main statistical concepts that we're going to look at are mean, median, mode, and range. Okay, so let's define these really quickly. So a mean is the average. And so you calculate the mean by taking the total sum of all the values. And then divide by the number of values that are being combined. Okay, so there's your mean. Next is a median. The median is the middle value when you sort or rank your items from least to greatest. Okay, and there's two kind of scenarios for calculating the median. If there's an odd number in the set, so if there's an odd number of values in the set, that's just the middle value. But sometimes there's an even number in the set. If that's the case, you're going to, as you start to work from the outsides in, you're going to have two middle values. And so if that's the case, the median is just the average of those two middle values. Okay, now there's one more concept I'm just going to write right here called the mode. Mode is the most frequently repeated value. And a value needs to be repeated for it to have a mode. So if there is no value that's repeated, then that means that there's no mode for that set. And then the final value here, the final concept, is the range. And the range is just the difference between the highest and lowest values. All right. So let's kind of take a look here quickly, or at the first. Mean and median are going to be the ones that are most common. Okay? So to find the mean, what you're going to do is you're going to add up all the values and divide by the total number of values that you have. Here's the nice thing. They give you access to Desmos, and if you look down here in this the keyboard and under functions, there's a number of different statistical functions that you can use. Okay? Mean and median are two of those. So I'm going to calculate the mean, and I'm just going to list my values. I don't have to order them or anything. I can just list them. So 10, comma 4, comma 5, comma 12, comma 5, comma 13, 11, 12, 5, and 3. Once I list all of those, it's already embedded in the function find the mean, and so I see that my answer is 8. Okay, so I do strongly recommend for mean medians, you can use the calculator to help find those. All right, so see if you can do the same thing with the second question, find the median. Okay, I'm going to show you both how to do it on a calculator and to do it by hand. Doing it by hand in the form that they give you right here is probably easier to do, but you can still do it with a calculator, and it's not going to waste too much time. If you search for the median command in that the keyboard drop down and under the statistics functions, you can find it, or you can just type median. Okay, and so if I type median and I just list my numbers, again, just treat it as a list. And notice it tells you 77 is your median when you perform that step. And now, let me show you how and why doing it by hand would probably be easier. And notice that this set of numbers is already ranked from least to greatest. If it wasn't, then I would probably type it into the calculator. But the fact that this one is already ranked from least to greatest, all that means is you just have to start counting from the outsides in to sort of match up what's left. So here I take my outermost, then keep working in the next remaining outermost, keep working in. And so notice I'm just kind of pairing these up as I work my way in, and now I'm left with just the one time. This one number remains. That means I had an odd number of values in this, so 77 is my median. If I had an even number, so let's say 77 and 78 wound up being the middle values when you start working from the outside in, then it would be halfway between those, so the 77.5 would be how you would calculate it. Okay, but it is easy if you take a list that's already sorted, to just count and find the median. All right, see if you can answer the question right below that, again, using these concepts. So ideally, you can look at this and you see why the answer needs to be what it is, right? Because you see that all 4 values from data set X are contained in data set Y with the addition of one more number that's much larger than even the average of the remaining ones. Okay, so what that means is that data set Y has to have a larger average, right? Because it's the same set of numbers plus a number that's much bigger than what the average score or what the average number is anyway. So I know that Y is greater. I can confirm this if I wanted to. I could type in all of these, so 5, 7, 7, 8, and I could take the mean of the next set, 5, 7, 7, 8, and 15. And notice the Y has an average of 8.4, X has an average of 6.75. So the average of X is less than the average of Y. And so this second option would be your answer. Okay, but again, that should be somewhat intuitive even without doing the calculations. All right. To answer this last question right here, okay, this has to do a little bit with frequencies, which we'll talk about when we go back to the previous slide here. But when you are finding an average, and it gives you 2 different sets. So you have set A and set B. Set C is consisting of all of those, and it wants you to average it all out. And you don't know, there's 84 buildings with an average of 30 meters each. You don't know what each building's height is, but you do know that if they each average 30, then the total sum of all of those buildings' heights is going to be the number of buildings, and just assume each one has the average height. So what we can do is we can find the total height of building A is going to be, or the total heights of the buildings in set A are going to be 84 times 30, right? That's the total sum of all of the A buildings' heights. We're going to add those to the total sum of all of the B buildings' heights, which is 63 times 51. And we're going to divide that all by the total number of buildings involved in the whole calculation, which is 147. So you don't have to know each one, and you're not going to try to list out 84 different numbers. But if you just take that calculation of 84 times 30 and then add that to 63 times 51, and then if we take that whole thing and divide by the total number, 147, that's going to show us what our average building height would be out of all or both those sets combined. And so that's what you would use to calculate. All right. Like I said, we're going to move backwards here. I have the slides are kind of a little bit out of order of what I wanted to present. So I'm going to go back to the slide right before this. And it involves the concept of frequency, which the word itself should be intuitive. It's the number of times a value shows up in a data set. And so when you look at this value of 32 appears 3 times in data set A, but 8 times in the data set B, and so on. Okay, so I want you to see, can you use intuition here and logic to figure out which of these answer choices would need to be correct based on what you see here? If you wanted to calculate it, you could. Right, you would just add the frequency times the values, and then you would compare the means. But you should see, right, when you're looking at 850s versus 350s is a much bigger difference than 832s versus 332s, right? When you're looking at the top of the highest numbers versus the lowest numbers. So the fact that, like here, these two are the same, right? Each data set A and B have the same values or same total values from 37, but you have more 38s and more 50s in the data set A. You have fewer, you have more 36s and 32s in data set B, but the fact that you have more of those higher numbers means that it's going to affect the average greater in that sense. So we know that A has to be a larger average, right? And so when you look at this, the average in data set A is going to be greater than it is for data set B. Like I said, intuitively you should be able to see it. If you want to confirm it with the calculations, you can. And you can go through and calculate the totals of those. Okay, the final problem here with these stats that I want to look at is this frequency tables. Okay, so I want you just to see which of these table of values is going to model the correct frequencies. So you see that the 5 shows up 3 times, 9 shows up 4 times, 15 shows up 3 times. And so if you see 5 is 3 times, 9 is 4 times, 15 is 3 times. The only one that gives you the correct number of times that the values show up is this option B, the second option there. Right, the last type of question, or the last one that I want to actually talk through is if we go to this final slide, and I just want to talk about this model right here. Okay, this is called a box and whisker plot. We really don't use these. We don't talk much about these here. And so I just want to point out, since they may appear on SATs, just to go through what the different elements mean. So the portion that's the box, and it gives you quartiles. It means that like 68% of the pieces, or a certain percentage of the pieces, fall within each of the boxes there. Okay, and so it just gives you a kind of a dispersion of like how likely it is that the values are going to be that close to the middle value. The middle value, the key to this is one of two things. This vertical bar right here, this is your median. Okay, so the vertical bar represents the middle number when you rank them in order. And then the other thing that you might need to play or think about with these is the total range. Okay, so that seems to be the two things that are played on or called on the most. Okay, so based on that, the box and whisker isn't going to give you anything about the means, okay, the averages. You don't know specific values, you just know sort of the spread of the values or the range of the values. Okay, but you do know specifically where the median is, and so when you look at this, the top group 1 has a median of 31, and group 2 has a median of 33. And so looking at that, it allows you to answer this question. The median of group 1 is less than that of group 2. And so that's the piece of information that you can take away from that graph or that plot.